All right, a third example, solving a rational function. So let's first start by putting a 1 under that. And then the next step, I'm going to rewrite the equation, and I'm going to leave a little bit of space. And when I get to the right-hand side, I'm going to factor out an x. When you do this, you can just more easily see what your two factors are. Okay, so my denominators, I've got an x and a 1 and an x times x plus 1. And I want to multiply by the largest. So I'm going to multiply everything by this. So let's do that. Each term gets multiplied by x times the quantity x plus 1. And this one gets multiplied by x. Let's get rid of that there. Times x plus 1. And the right-hand side gets multiplied by x times x plus 1. Okay, so looking at our first term here, we have x divided by x, so those are going to cancel. And then I'm just going to be left with x plus 1. And I'll still show it in parentheses for right now so you can see where it comes from. And this next term, I'm just going to multiply all of this out. So I'm going to end up with 2x times the quantity x plus 1. I'll do that on the next go-around. And then the right-hand side, well, this x cancels with this x plus 1 cancels with this x plus 1, and I'm left with, on the right-hand side, 1. And then let's just go ahead and multiply this middle term out, and let's drop parentheses and combine like terms. So I get 2x squared plus 2x equals 1. Combining like terms and rearranging the order, I have 2x squared plus 1x and 2x's are 3x's, and then I have plus 1, and this equals 1. Let's subtract 1 from both sides. So now I have 2x squared plus 3x equals 0. So this is what we have to solve. And let's take it up here and work on it up here. So I have 2x squared plus 3x equals 0. Let's factor out a common factor of x. So I have 2x plus 3 equals 0. Set each of the factors equal to 0 and solve. So we get x equals 0. There's one of my solutions right there. And then let's take this other factor. 2x plus 3 equals 0. Subtract 3 from each side. You get 2x equals negative 3. Divide both sides by 2. And I'm going to write it under here. X equals negative 3 halves. So there's my other solution. And we know by now that we need to check all of these. Let's check this one by graphing. So here's my calculator. And I have already typed in the y sub 1, I typed in the left-hand side of the equation, 1 over x plus 2. And then in my y sub 2, I typed in, that won't stay. Oh, guess that won't stay. On the right-hand side of the equation, I typed that into y sub 2, 1 over. And notice I have to put parentheses around the whole denominator here. Okay? And now we're going to check this one by looking at the table. Let's first graph it and just kind of see what it looks like when I graph it. See if that's any helpful. There's the left side, there's the right side, and I don't know about you, but that just looks like a big mess to me, and it's very hard for, with my asymptotes in there and everything, to see solutions. So I like to use the table. Okay, so we saw that our one solution was 0, so let's go to our table, and I'm going to start my table at 0, second graph, there's 0, and look what happens when I look at the table. Both here, let's do it on the screen, see it here. Okay, so when x is 0, both y sub 1 and y sub 2 are in error. That's because I have an asymptote there. So, let me clear this a minute. That means that x equals 0 is an extraneous solution. And what I like to see on the paper is I like to see this actual solution, x equals 0, and then I want to see you cross it off and write the words extraneous. That shows me you've calculated x equals 0 and that you've checked it and determined it's not a valid solution. Okay, and then don't give up at this point. You still got to check the second solution. Sometimes, actually, both of them are extraneous. So let's go check this next solution. Go back to table start, and it was negative 3 over 2, I believe. Just type that right in, and then go to your table. And sure enough, when x is negative 3 over 2, my y sub 1 and my y sub 2 match. That means that's a valid solution. So we know that this is the one and only true solution because the other one is extraneous.